Yo guys, subscribe to Madman.
Hey everyone, today we're going to be doing this cool and weird limit. It's the limit as x goes to infinity of x to the power of 1 over x. Now let's just take a moment to think about what that means. We have a limit as x goes to infinity of x to the 1 over x. As x goes to infinity, we're going to have, well, it's going to go to infinity, and 1 over x, as x goes to infinity, goes to 0. So you have something of the form infinity to the power of 0. Okay, and that's weird, we don't know what's going to happen there. It could be 1, could be 0, could be e, could be anything. Okay, so what might be nice to do, because we have that power, is to take the natural logs. Okay, so we just say that this is y, and then take the natural log of both sides. As this goes to infinity of, I don't know why there's a different colours, of x to the 1 over x. Okay? But because the natural log is a continuous function, we can bring the limit outside. So we have, this is equivalent to the lim of the natural log, this is as x goes to infinity, of the natural log of x to the 1 over x. And that's why we introduce the natural log, is because we're going to have the natural log of x to the some power. And then when we have that, we can bring down that power. Okay? So this is all equal to the natural log of y, remember? So this is equal to the lim as x goes to infinity of, well, this is going to be 1 over x times the natural log of x. Okay, so now as x goes to infinity, we have infinity, 1 over infinity, and we have infinity here. Okay, so now this is the limit of the form infinity divided by infinity. And this is one that we know how to work with. We can apply L'Hopital's rule. Okay, so L'Hopital's rule says that this limit is equal to the limit as x goes to infinity of the differential of the two things. So if I just rewrite this a bit neater, so it was 1 over x, because I brought that power down, but I'm just going to write that as divided by x instead. Okay, but this limit, by L'Hopital's rule, is the same as the derivative of the top thing, divided by the derivative of the bottom thing. Okay, well divided by 1 doesn't do anything, so this is equal to 1 over x. Oops, sorry, this is equal to the lim as x goes to infinity of 1 over x. Well, now that's just a limit that we can plug in, and as x goes to infinity of 1 over x, this goes to 0. So this is equal to 0. Okay, and we are done, but not quite, because this wasn't our answer to our limit. This was the natural log of y, and we just had y to start with. Okay, so we have the natural log of y is equal to 0, and therefore, raising both sides to e, so we have e to the natural log of y is equal to e to the 0, and this is a 0, sorry, that looks terrible, and then e to the natural log of y is just y, so we have y is equal to e to the 0 is 1, so this limit is equal to 1. Perfect, thank you for watching. If you enjoyed, please like and subscribe. Leave any comments and suggestions, I would really appreciate that. And I will see you next time.